Chapter 2, Part 2. So we're going to start here with where we left off, and we're going to start at 4.3. So looking at 4.3, we have already done epithelial tissue, and now we're going to look at our connective tissue. So we are talking about tissues. So with our tissues, what we're talking about with this connective tissue is this overall concept of how important it is. So we're going to talk about a lot of different types of tissue and where they may be found, because connective tissue is the most abundant and widely distributed of all of the primary tissues in our bodies. So it's really, really important. Some of its main functions are binding and supporting, protection, insulation, storing reserve fuel, and transporting substances through the blood. So when we're looking at our overall functions for this connective tissue, the ones I want you guys to keep in mind as we're going is really this binding and support, because the tissues we're going to talk about connect things, so that's important. But they're also going to protect and insulate and store things. So just keep those in mind as we are going throughout these next couple of sections. There are 4 main classes of tissues, and we're going to talk about each one as an overview. So the first one is going to be connective tissue proper, and this just is a family overarching kind of header name. We're going to go down to look at these. This connective tissue proper, again, it's a family name. It's kind of an overarching name. This is going to be where you're going to find the tissues that are perfectly matched for all of the structural connective tissue that we're going to talk about. Then we're also going to have the second set, which is going to be our cartilage. So cartilage that you have in your body will actually fall under connective tissue. And then some others that you may not know are going to be bone and blood. So we're going to have our bone and we're going to have our blood. So when I said that connective tissue was the most abundant and widely distributed, all of our bones and all of our blood is considered a connective tissue. So we have a lot of that. So if you're looking at this chart right here, this column, all of these subclasses, we're going to talk about all of these different types of cartilage, connective tissue broken down. But these are the 4 main classes and the main functions. So all of these are going to be under the header of connective tissue. So what are the common characteristics of connective tissue in order for them all to be put together? Because bone and blood are very, very different. So why are these considered in the same class of tissues? So there are 3 main characteristics that make tissues different from other types of tissues. So the first one is that they are all going to have the same embryonic origin, meaning after fertilization of the egg, as the embryo starts to divide, it'll divide into 3 different layers. Connective tissue comes from the same layer, and it will come from the mesenchyme tissue. So essentially, they're all going to have the same heritage. So that puts them in the same category. They're all going to have some degree of vascularity. So like we said with epithelial tissue, where there is no blood supply, it is avascular. This is going to be degreed avascular. So when we're talking about our cartilage is actually going to be avascular, which means not vascularized. But then when we get to one that is going to be our super vascularized, highly vascularized, when we get to it, it'll be bone, surprisingly enough. So there's going to be some degree of vascularization or some degree of blood supply. And then the most common characteristic that we're going to spend the most of our time on is going to be something called the ECM, or the extracellular matrix. This extracellular matrix is outside the cell. So all of our cells in this tissue are suspended in this extracellular matrix. And essentially, it allows it to have that support, but it also allows it to endure tension, any kind of torsion or twisting, but also is that binding and more of that glue connection. So the extracellular matrix. What makes up this extracellular matrix? There are going to be 3 additional parts that are going to kind of make up this whole thing. So all connective tissue all of them, it doesn't matter what of it, all the connective tissue will have three main elements that will make up its structure. You're going to have this thing called ground substance. You're going to have fibers, and you're going to have cells. So these first two will make up the extracellular matrix. So it'll be the ground substance and our fibers. This is what's going to make up this. So when we said that connective tissue had these characteristics of the embryonic origin, the degree of vascularity, and the extracellular matrix, it's because all connective tissue is going to be made up of some sort of ground substance, which we're going to define in a second, and fibers. But there's also another element is going to be a bunch of different kind of cells. So we're going to talk about those as we move on. So it's the way these are all arranged, which will give us the different types of connective tissue. So first, what is our ground substance? When we're talking about ground substance, to me, I think of something hard, but it's really going to be like an unstructured semi-fluid material that is found between the cells. So it's not a liquid, but it could be kind of liquidy. It's not a solid, but it could be kind of hard. So it's an unstructured material that fills the space between our cells. So it's a ground substance. Inside this ground substance, it will have a couple different parts. In it, you will find this thing called interstitial fluid, which is very, very important. You will also find cell adhesion proteins. So like I said, our connective tissue is going to be more of a glue. So that's where you'll find those sticky glycogen cell adhesion proteins. You'll also find those protoglycans, which would be the sugar protein. And then some sort of water. So this is where you're going to get, depending on where it is and what type of connective tissue it is in, there'll be more fluid, more protoglycans, more water, but that is the ground substance. It's the glue between the cells. And then you're going to have something, so that was the first one. The second one was our fibers. So when we're looking at the fibers that make up our connective tissue, there are three types of fibers. The first type is going to be collagen. Collagen is going to be the most abundant type of fiber, but it's also going to be the strongest. So this is going to be the Mac Daddy one that we want. The second type of fiber you're going to have is elastic. I've also seen it as elastin, but you'll see it as elastic. These are going to be long, thin fibers. And they are not going to just be the strongest, they're going to allow for stretch. So that's very important as we're going to talk about some of these different types of connective tissue. And then the third type of fiber is going to be a reticular fiber. And a reticular fiber is going to be a shortened, fine form of collagen. So it's going to fall into the first category from its kind of overall structure, but it's not going to be as abundant. So when these come together, essentially they're going to branch a whole lot more in order to give a little bit more give. So it's not going to be stretch as much as it is not quite so strong. There's going to be a little bit of flexibility to it. So these are the three types of fibers. As we go through, you'll be able to see these. So we had our ground substance, we had our fibers, which make up our extracellular matrix, and then the third thing is we're going to have our cells. So this is what's going to make up our connective tissue, our cells. So each of our connective tissue is going to have two forms of cells. So all will have two forms. This form will be in a immature cell or an immature form that will then become a mature form. So we're going to talk about a couple different names, but they're all going to have this kind of two different states. So we're going to have a fibroblast. Fibroblast means it is going to be a immature cell. And this is going to become connective tissue proper type cells. This is where you will find this. Whenever you see a chondroblast, chondroblast, again, is going to be the immature form. This will eventually be our cartilage cells. And then when you see an osteoblast, that will eventually become bone cells. So the blast is going to be the immature cell. So you can see these over here. The mature form is going to be a cyte. So if our blast is the immature form, we are going to have a cyte, which means cell, in our mature form. So we're going to talk about these as we go. We'll start talking about a bunch of cytes. Essentially, that suffix just means that it is going to be a cell. You also have a couple other different types of cells in our connective tissue. You're going to have fat cells, which are going to store nutrients. You're going to have white blood cells, which will help with our tissue repair, mast cells, which will help with our immune response, and our macrophages, which is going to help with devouring our foreign substances and kind of protecting us. So those are the main types of cells we're going to have. So next we're going to go into our types of tissues. So this is going to start with our first class, which is going to be our connective tissue proper. So we had connective tissue proper, cartilage, bone, and blood. So this is connective tissue proper. Inside this class, we're going to have a bunch of different types, but as we go, you'll notice that we're looking for some of those things. We're looking for our extracellular matrix with our fibers and our ground substance, and we're looking for our cells. So as we go, you'll be able to point out and look at these things. Inside our connective tissue proper, we're going to have these four classes. So we are essentially now just in this one right here. So as we go through our connective tissue, we're going to live here first, and we're going to go through all of these types, and then we're going to move into, that's 1, 2, 3, and 4. So this is our first part right here, but this is a great chart to remember if you're trying to understand how things relate to each other. Focusing on connective tissue proper, the first type. So in this world, this is going to be everything except our bone, our blood, and our cartilage. There's going to be two subclasses. So you're going to have the subclass loose connective tissue proper. So it's loose connective. So it's still our connective tissue proper, but it's loose connective. So what this means is when we have our loose connective tissue, that essentially just means that the ground substance is going to be dominant. That is all that means. We don't have as many fibers, we don't have as many cells. It's going to be the ground substance that is going to be dominant in our loose connective tissue proper. So a couple different kinds. We're just going to go through these really quickly. The first kind is going to be areolar. And this areolar connective tissue, we're going to do kind of like what we did before with function, structure, and location. So the function of this is going to be supporting and binding our other cells together. It's going to hold things together. It also has the ability to store some things. So this is going to be the structure, is a loose arrangement of fibers. So there's not a ton of fibers. There will be a lot of ground substance. So a little bit more of that like liquid in between. Where you find this is actually a lot of places. So this is going to be the most widely distributed type of connective tissue. So if connective tissue is the main type of tissue we have, this areolar connective tissue is the most widely distributed type of connective tissue. It is everywhere in our body. So here's an example of what it looks like. You can actually see here are fibers. We have our elastin, our ground substance, and some collagen. You can see the cells in the back with our nuclei, and then all of the white space is actually the liquid. So that's one type. Another type of loose connective tissue where ground substance is primary is adipose. Adipose is our fat tissue. So the function of our adipose tissue is going to be to store our nutrients. As it's storing your nutrients, how it does that, the structure of it, it is going to essentially have, if it's storing nutrients, it will also include a fat droplet, which is going to be a triglyceride. And this fat droplet will actually take up most of the cell volume. But it's going to be a very limited amount of matrix. So it's not quite going to be so fibery and ground substance. So that's the structure and the function. You will find this essentially everywhere in your body, anywhere that you're going to need to have these types of structures. It is about 18% of a person's weight is going to be in this adipose type tissue. And it will usually accumulate in subcutaneous, which would be right underneath the surface. And that is really going to be for this insulation component as the structure, as the function. So you can look right here. Here is actually your fat droplet. And then the cell is actually around it. So that's the connective tissue proper of adipose tissue. The other type we're going to have is going to be your reticular connective tissue. So looking at this reticular connective tissue, this type of tissue is going to, with the function, structure, and location, its structure will actually look very, very, very similar to areolar. But it's going to have a slightly different take where it's going to resemble areolar, but the only matrix fibers will be reticular. So where the other one had all of the matrix fibers of collagen, reticular, and areolar, this is only going to have the reticular, and collagen. This is only going to have the reticular fibers. So that's going to be slightly different. The function of this is that it really is going to be involved in areas where you're going to have your lymph system. So he is responsible for areas where you're going to need to have your lymph nodes and your lymph system. So he's going to be, the overall function for this is going to be support of our blood supply. Specifically going to be our white marrow, our blood supply, our blood cells. But that is going to be our reticular connective tissue. And you can kind of see it right here. You only have one type of fiber. That's going to be the reticular fibers. Okay, so that was all of our loose connective tissue. This is going to be the next subclass, which is going to be dense connective tissue. So this is different than loose connective tissue. This is dense connective tissue where the fibers are going to be dominant. So it's dense. There's not as much liquid. A couple different kinds. 3 different kinds of dense connective tissue. So first one, dense regular connective tissue. I'm going to give you a helpful hint to remember these. Dense regular connective tissue. This type of tissue has a very, very high tensile strength. These are going to be the structure of this. These are going to be closely packed bundles of collagen fiber. So lots and lots of fibers. And these are going to all run in the same direction. So it's dense, regular. So dense means a lot of fibers, and they are all going to run in the same direction. They're going to be in parallel. That's what makes it regular. So that is essentially going to give it its function. when it has this structure, it's able to withstand a lot of tension and pulling and stretching and twisting. So it has the ability to maintain the integrity of its shape. It is also going to be poorly vascularized. There is not a lot of blood supply for this guy. But where do you find this? The location? You will find these wherever you have tendons and ligaments. So tendons and ligaments are examples of this type of tissue. So that's where you're going to need to connect the bone to a muscle, or a muscle to another muscle, or a bone to another bone. So you're always, or sorry, your bone to a muscle, or a bone to a bone. You will always need some sort of connection. Again, connective tissue. It will be this type of cell. So these are going to be this dense, regular connective tissue. It has high tensile strength, but also it is poorly vascularized because it is mostly fibers, and these fibers will all run in the parallel direction. So you can kind of see right here how they all run like this. The opposite is going to be dense, irregular. So dense, irregular connective tissue. It is dense, so there's still going to be more fibers, but dense, irregular connective tissue, the structure of this is you're going to have very, very thick collagen fibers. And they are going to be arranged very irregularly. So in a bunch of different directions, a bunch of different pulls, more than one plane. And so when you actually have the ability to have this in a bunch of different directions in these sheets in many, many directions, it's going to allow for this to have the function of being able to withstand tension in very different directions. So not only does it withstand tension, because both dense regular and dense irregular do, but it will allow you to withstand tension in different directions. So where you will find this is locations where you need to actually do that. An example, this is going to be the skin. This is where you will actually find your skin cells. Is going to be, you're also going to find some dense irregular connective tissue. Okay, so you can kind of see here how it's all, here's a great image of it. So another type of dense connective tissue is going to be elastic connective tissue. And this elastic connective tissue, the ligaments are going to be very, very, very elastic. So it's going to almost be a stretch for these. And then you're going to find these wherever you are going to have walls or things that need to expand. So an example of this as a location. So your function is going to be elastic. And the location of this is going to be in your arteries. So if this is going to be a cross-section of my artery, and this is where my blood will fall through, you will actually have elastic connective tissue here that will allow you to essentially create a wider or a smaller lumen and be able to control that because you'll have elastic tissue in arteries. Okay, so that is our connective tissue, dense connective tissue. Our next type is type 2, which is going to be our cartilage. Our cartilage is a second type of dense connective tissue proper. This is going to be incredibly inflexible. So this is going to be incredibly rigid. Depending on the type of cartilage, there may be some flexibility, but it's going to be very rigid. And the function of our cartilage is going to be to withstand tension, but also to withstand compression. So it doesn't have the ability to be pressed down and made smaller. This type of connective tissue does lack nerve fibers. There's no essentially sensory input coming from this connective tissue. And it is also going to be avascular. So this is going to be the type of connective tissue proper that does not have a blood supply, so it's avascular. And this type of cartilage is actually going to be made up of a ground substance that is going to be mainly water, and it's going to be a lot of our sticky proteins. So that's really, really important in order to maintain. In fact, it's going to have so much water that your extracellular matrix is 80% H2O. So that's going to be a lot of liquid. This type of cell is going to have a type of, this type of tissue is going to have a cell called a chondrocyte, and then it is coming from a chondroblast. So it will have the cell that is the immature cell, which is our chondroblast. Now we're going to start talking about the cell that is a chondrocyte, and that is our mature cell. So as we're going, that's the cell that's going to be the predominant cell type. There's 3 types of cartilage, and we're just going to kind of run through these real quick. Hyaline cartilage is the first type. This can also be called gristle if you were ever to eat a steak. It is the most abundant cartilage that you have. So most of the cartilage that you have in your body is going to be made up of this particular type. It has a lot of collagen fibers. So that's going to be the primary fiber here. And it is going to be found wherever you're going to have things connecting, bone to bone connecting. So it's called articular ends. So it'll be, let me rewrite that, articular. So it'll be the bone ends in order to connect to another bone. You'll also find this one at the tip of your nose. It'll also be connecting your rib to the sternum. So if you think about it, your rib to your sternum, you don't want that to be super flexible, or you do not want it to be super flexible. You want it to kind of be sturdy. So that's where you can find some hyaline cartilage. The second type of cartilage is going to be elastic cartilage. And this is similar, almost exactly identical to hyaline cartilage when you look at it underneath the microscope, except it will have more elastin fibers. So that's kind of what makes this guy different. This is where you're going to have a lot of strength and a lot of stretching, where you need to have some of that stretchability, if that were a word. So the location where you will find this guy will be your external ear, your auricle, and your epiglottis. So the connection between your trachea and your esophagus that directs air down your trachea and food down your esophagus. So that's that kind. The last kind is going to be fibrocartilage. And fibrocartilage will actually kind of live in between hyaline and dense connective tissue, dense regular connective tissue. It's going to have a lot of chondrocytes and collagen fibers. So it's kind of going to have mixtures of both. What's important for this is it is going to be compressible, which means you have the ability to push down on it and to have it withstand tension in heavy pressure areas. So places that you will actually find this is going to be in between the vertebrae, or your intervertebral discs. Also in your knee and your patella. So if you've ever had someone who's torn your ACL or your anterior cruciate ligament, they may have also had some damage to the fibrocartilage in their knee at the same time. So that is your elastic, your fibrocartilage, and your hyaline cartilage. So that was your connective tissue proper and your cartilage. The next type, here's some examples. Another example of those 3. So moving on to our third type, we were going to have our bone. So we're going to talk more about bone when we get to the skeletal system, and I think it's chapter 6, 7, and 8, I believe. 7 and 8, we're going to talk a little bit more about that, but to give an overview of a bone, whenever you see the prefix osseous, that will mean bone. So that's the world we're living in. In this particular type of connective tissue, the matrix is hard because it will have a lot more collagen fibers. So if you have a lot of those fibers, it will essentially make it a little harder substance, and it will actually add some inorganic calcium, which will be a salt. The salt and the extra fibers will make the matrix of the bone, which makes the bone itself, essentially really, really hard. So you will also have an immature cell. So the immature cell is going to be an osteoblast. Again, blast will always mean immature. And then your mature cell is an osteocyte. So that's the type of cells we are going to be talking about. So your osteoblast will actually produce the matrix, but your osteocytes are going to be the mature cells inside. So there's going to be these characteristics. Another factor about this is that it is highly vascularized. There is a lot of blood supply to your bone tissue. It doesn't seem like it, but there is. And then the last type is going to be our blood. So this is really going to be covered in A&P 2, but this is going to be the fluid or the liquid in our blood vessels. So not just our blood cells, but just the red blood cells or white blood cells, but it's going to be all the fluid inside of our blood vessels. So this is going to be a little bit different because it is an atypical connective tissue. So how do we have bone and blood in the same category? It's an atypical connective tissue. And there's a couple reasons why it's an atypical connective tissue. It does not do connection. So it does not connect things. That's one way it's atypical. It also does not support things. So those two main functions of connective tissue, this doesn't do. But what it does do, it does develop from that same embryonic tissue, the mesenchyme. So it still has that foundation. And what's interesting is that it does have the fibers, the matrix, which is going to be considered the plasma, and it does have cells, which are going to be considered the white blood cells and the red blood cells. But it also is going to have fibers. So it's got those three characteristics that all connective tissues have. So it does have them. The fibers are actually going to be the proteins that are formed from clotting. So these are considered fibers. That's why this is considered a connective tissue. So this is important to note why it's an atypical connective tissue. It doesn't meet the two criteria, but it does meet the criteria for the embryonic tissue and for the characteristics of having matrix, cells, and fibers and what those are. But its function is going to just be a little bit different. So this is really important to know all those pieces. Okay, so that's our connective tissue. We've done epithelial and our connective tissue. This is going to switch gears into our next type, which is muscle tissue. In our muscle tissue, this is going to be highly vascularized, well vascularized. It is responsible for most types of movements. And this one, your muscle cells that we'll talk about when we get there in chapter 9 and 10, these are going to be called myofilaments. It doesn't sound like a cell, but it actually is. So that's the term that we'll be using for our muscle cells. And there are three types: skeletal, cardiac, and smooth. So the three types. first one is going to be skeletal muscle. We will go into this more. So this is going to be an overview. Skeletal muscle tissue, this is going to be voluntary. So when you think about this type of muscle, you choose to movement. You are consciously controlling it. It is voluntary. It's going to connect other types of things in our body. So it does fall into the connective tissue, but it will actually attach and connect to bones. That is what will anchor this tissue. And then it will cause those bones to move. So these voluntary muscles, these cells, are also going to be multi-nucleated. So there's going to be in one cell a lot of nuclei. And these muscle cells are going to be striated. So multinucleated and striated. So when we're looking at this skeletal muscle, here is our one muscle fiber. Think of these more as a kind of like a straw. And you can see the striations down the muscle fiber. And all the nuclei that have been pushed to the side, that is going to be our skeletal muscle. So voluntary, striated, and multinucleated are the important pieces. The second one is going to be, the second type is cardiac muscle. And cardiac muscle is going to be found only in the heart, so that's important. This is going to be involuntary. So meaning your heart will beat, your cardiac muscle will do its thing without you having to consciously think about moving the muscle. So it's going to be an involuntary muscle. And as it contracts, it's not moving bones, it's going to be moving blood throughout the body. These cells are going to be uninucleated. So there's going to be only one nucleus. And they are also going to be striated. And these are going to fit together through joints called intercalated discs. So that's how they are going to fit together. So the important thing is involuntary, uninucleated, and striated. So when you look at this cardiac muscle, you can see here is my muscle cell. You can see how there is a little bit more of that wall between the different cells. That's because of that intercalated disc, and there's not as many nuclei, so it's only one nuclei per cell. And then the third type we're going to have is going to be smooth muscle. Smooth muscle. This is also going to be involuntary. You do not choose to use this type of muscle. This is going to be found in walls of our hollow organs. Think about your digestive tract or your lining of your arteries. This is going to be these cells or this type of tissue. There's going to be no visible striations. So it doesn't have that striation appearance that all the others have we talked about. And these are only going to be uninucleated. So there's only one nuclease in this, but they are involuntary, no striations, and they are uninucleated. So you can kind of see how this tissue here looks a little bit different. Okay, so our next type, again, we're just going to do an overview of this because we're going to talk about this the latter half of this course, nervous tissue. So these are going to be cells in our nervous system, specifically our brain, our spinal cord, and our nerves. And these are going to be mainly involved with controlling all of the body's functions. So pretty much everything that you think, feel, do, or see, hear, smell, all of those will be involved with our nervous tissue. There are two types of cells. And they are going to be, the first one is going to be neurons, which is what most people have heard about. Neurons are going to be specialized cells for communication. So they're going to conduct nerve impulses, is what it's called. But essentially, they are communicating things from point A to point B at a very, very fast rate. They're going to respond to some sort of stimuli and then transmit that communication over a long distance. So these, when we get there, this is our neuron. It looks a little bit different. This is essentially going to be our cell. But we'll talk about this later half of the course. And then the second type, I guess it's not actually on here, that's going to be neurons. And then the second type you'll have is called glia. And glia is going to be the cell that is going to be a supporting type of cell. And it's going to be found around the neuron. And it's going to be non-conductive, so it doesn't actually transport communication. And it's going to essentially hold the neurons in place. So we'll talk briefly about glia when we get there. Okay, so 4.6, we've talked about the connective tissue, epithelial tissue, muscle tissue, and nervous tissue. But we're just kind of flashing back to that epithelium and connective tissue real quick. When we're talking about membranes, things that need to cover and things that need to line, we're talking about membranes. So this is kind of going to be a combination of two of these types of tissue. So these all are going to cover parts of our body, or it'll line part of our body. So there are going to be three types of membrane, and each one is going to have at least one connective tissue type and one epithelial tissue type. So when we put these two together, we're going to make a membrane. So as we go, we're going to talk about these terms of a connective tissue and epithelial, but just to bring up, that's what we're going to be doing. So there are three types to these membranes: cutaneous, mucosous, and serosus. So cutaneous membranes are essentially is lining the outside surface of our body. So it's going to be another name for our skin. So it's going to cover. This type is going to have epithelial tissue. That's what the E stands for. And it will be called keratinized, stratified, squamous epithelium. So you should know what all of those means to do keratinized, stratified, squamous epithelium. We haven't talked about the keratinized yet, but that will be covered in chapter 5. But that is the epithelial tissue, and underneath that epithelial tissue, it will have a thick layer of connective tissue, and that will be our dermis. So one will be our epidermis and one will be our dermis. So this is a dry membrane, meaning it's exposed to air. It is not going to have any kind of liquid that makes it up. So here's your skin. Another type is going to be your mucosous membranes. And these are going to be mucosa, is sometimes what you will see. These are going to be wet membranes. So they're all going to have some sort of liquid or mucus or secretions, but they're going to be moist or wet membranes. These are going to line hollow the inside of our body. So these will actually line the inside of our body that open to the outside. So like our digestive tract is inside our body but has openings to the exterior environment. Our respiratory tract, also our urogenital tract, will have those. So the epithelial tissue in our mucosa membranes is going to be stratified squamous. Sometimes it might be simple columnar. So that's the type of epithelial tissue that you'll make up a mucosa membrane. But then the connective tissue will be a laminar proper, which is a loose connective tissue. But what you'll see this called as, you'll see it called a lamina propria. Lamina just means layer. So that's going to be a wet membrane. You can kind of see how this is lining the environment inside our body, but has a connection to the outside. And then the last type is going to be a serous membrane or serosa. A serous membrane is also a moist membrane. So this will also be found in areas with a slippery serous fluid. So it will also be a wet type membrane. And this is going to be found in closed body cavities. usually on the ventral side, but these are going to be found in closed body cavities. So an example of this would be like the lungs and the heart, things that do not have an exterior entrance to the environment. The epithelial tissue is going to be simple squamous, usually, and the connective tissue is going to be loose areolar tissue. And that's what's going to make up this type of serous membrane. So you can see how this is actually around your lungs, not lining the inside of your lungs. So this is going to be found in capillaries, connective tissues. It's going to be really, really, really important. And it will actually be named for where it is located. So as we go throughout this course, there's a couple different types of serosa that we'll talk about, whether or not it encloses the lungs or the heart or the viscera and abdomen. This last section on tissue repair, to go through this briefly on why we actually need to have tissue repair. So when we actually have some sort of compromised or damaged tissue, we need to actually repair it. And repair needs to be fast and rapid and fix the problem. So we are actually going to need to protect ourselves from injury and from any kind of invasion. So once there's an issue, we need to be able to take care of it. So there's two different types of things. Well, it doesn't actually describe it, but we're going to do it. There's an immune response and an inflammatory response. So just to define those real quick. An inflammatory response is a non-specific reaction that develops quickly. So an inflammatory response is not super specific. It is just you react really, really quickly to essentially any kind of allergen. Whereas if you have an immune response, so like an actual true allergy, you essentially are going to have a very extremely specific reaction. It knows exactly what is happening. And this will actually take a little bit longer because it has to have the recognition of whatever's going on. So you can have an immune response. Let's say you get stung or bitten by a mosquito and you get that little immediate kind of bubble that comes up of a bug bite. That's an inflammatory response. It happens really, really quickly and it's non-specific. But for someone who might be allergic to that, or if it was a bug bite of something that might be a bee sting, you'll have that inflammatory response, but then the actual immune response will be the body's reaction that is specific to that trigger, and then it takes a little bit longer for that process to occur. So that's the two difference between inflammation and kind of an immune response. So as we're going to kind of go briefly through this, we're going to do repair. So the first thing that happens with repair is you're going to have some sort of inflammation. There's going to be an immediate reaction to what is going on. And with this inflammation, you're going to have dilation of your blood vessels, and you're going to essentially going to allow things, your permeability will have, there will be more permeability in your blood vessels. Things can move through quickly, and then you'll get clotting. So inflammation will happen immediately after some sort of injury. So you can see how we are going to have inflammation sets the stage. We're going to start with our blood clots, and we're essentially going to increase our blood supply. Step 2. As we're going through step 2, it'll be organization. So now that we've essentially told the body that something's going on, we need to organize and essentially be able to now repair. So this is technically the first phase of the actual tissue repair. Before that, you were just communicating there was an issue. So this is where you're going to have the blood clot that is going to be replaced by actual tissue. So you're going to have a blood clot that is formed in step 1, and now you're going to replace that blood clot with brand new, what's called granulation tissue. So This is where you're actually going to start to regenerate whatever the issue or injury was. So as you're going through that, you'll notice here that you've already laid down that blood clot and you're starting to regenerate all of the pieces. And then in step 3, what you're going to do is you're going to essentially regenerate the fibers. And it's going to be permanent repair. So this is where you've already done the blood clot starts to form underneath with new tissue, and now this is where you're going to have the scab that was happening that essentially becomes the surface level is no longer needed, and so the scab will detach. This is where you're going to have your epithelium really start to thicken and create a new exterior skin. So if there's going to be any type of severe cut, or you may or may not have underlying scar tissue, depending on how much that exterior layer of the skin, the epithelium, will need to be healed. You may not have a scar, you may have a scar, so you can kind of see how this is happening right here. Okay, why we actually care about tissue regeneration is because all tissues regenerate differently. Some tissues regenerate really well. If you get a paper cut, that heals really quickly. So some heal really well, some don't. The ones that regenerate well are going to be epithelial tissue. Your skin will heal very well. Your connective tissue, your epithelial, your bone. You break a bone, it will heal really well. Areolar connective tissue will heal very well. So will dense, irregular connective tissue. So these are the types that if you were to injure it, it'll heal very well. There's some that will heal okay. That'll be some regeneration. And this is going to be smooth muscle. So if you were to injure your smooth areas of smooth muscle, it may take a little while and it may not heal as well. Also, dense, regular connective tissue has some regeneration. But the problem is going to be weak regeneration. So this is where you're not going to really have a whole lot. So if you were to damage this type of connective tissue, you're going to have some issues. Skeletal muscle. It takes a while for skeletal muscle to fully heal together, and sometimes it doesn't always actually go all the way together. So skeletal muscle, and the other one is going to be cartilage. In fact, cartilage actually requires surgery to put back together. It doesn't just naturally come back together. And then the other challenging piece is going to be things that have no regeneration. So we do have certain types of tissues that do not have the ability to heal itself. And this is going to be our nervous tissue. But not only just our nervous tissue, it's also going to be our cardiac muscle. So the tissue that's responsible for communication in the body, our nervous tissue that controls everything, does not have the ability to regenerate after damage. This is why spinal cord injuries and any kind of stroke or traumatic brain injury causes so many clinical problems, because this type of tissue does not have the ability to heal itself or to regenerate after any kind of damage or injury. Cardiac tissue also does the same thing. So with a heart attack, you can damage your heart cells and your cardiac muscle cells, but you may not ever really be able to regenerate and heal those types of cells. So those are big clinical implications for those two types of cells that do not have the ability to regenerate. And that is where we're going to end chapter 4, part 2.